Hello and welcome to programming. Let's finish the series in this episode, and I hope to show you how to implement the goals and add a score to it. I assume that you have the project open. First, let's fix some errors from the last episode, namely line number 46. This should be 3, and I'll make this function a little bit easier to read by introducing a couple more constants. The first one will be different in the change rows, so static final, and different in rows. Let's call it the row. And if we are going to left, there's no row change. If we are going up, the row change to -1. Right is 0 and down is +1 +1. Likewise, for column change, left would be -1, up and down would be 0, and right would be +1. Now we can swap out the switch statement by the following code. We're going to get the new value of rows to be from a function of wrapping around when put in the row and incremented by that amount according to requesting direction, and the maximum that it can be is rows. And we'll do the same thing for column, so that should be column, that should be column, and the maximum is columns. That should be column. Okay, we're going to need a wrapping function that is going to return an integer given an integer of current value and the increment value and the maximum that it can be. Now this should return value plus maximum plus increment and mod by maximum. This is to return 0 when it's actually maximum. When the value plus increment is maximum, it should return 0, and when it's -1, it should return maximum -1. Once we have that, we can get rid of the switch statement. And we'll simply move by checking if the character from current maze number character at the new row and a new column is not 0, that means it can go. This would mean successfully move, and to move it we simply say info.position.rows equal new rows. Likewise, the column should be that. Now to make the constant more accessible, we are going to move it to common class called mover-info. So let's get rid of these and go to mover-info, paste constant in. Next I'll add one more constant which will give us the reverse direction. So the first one is left, and the reverse of it should be right, up, and the reverse of it should be down, and so forth. Save all of this, go back to game data and fix these error by add mobile info to it. Next we can try PacMan. So we'll run it by right click and run as application. As you can see, PacMan doesn't eat the pills. Now we'll make the PacMan eat the pills. So go to game data, and we'll need to add something to the update method. This is pretty simple. We are going to check if the PacMan location is in the pills. We'll remove that pill. So if pills contained PacMan location, so it's PacMan dot position, then we'll remove that pills. Pill is basically just position, so we'll remove it by remove PacMan dot position. If it's not at the power pills, then we'll check if it's actually in the power pills position. Same stop position, then we'll remove that power pills. Okay, how about we increment the score in here? So whenever the PacMan eats the pill, we are going to increase the score by 5. Likewise, we will increase it by 50. Now for contains and remove method to work correctly, we are going to need to make each object of the position is unique. This is how we do it. We are going to generate the hash code and equals method. Once we've done that, we should be able to run PacMan. Let's save all of these and then run PacMan, and it should be eating the pills, and the score should be up. Now we have some errors in here, which is dealing with concurrency problem. To get rid of this error, we are going to need to use one of the data structure for concurrency, for solving concurrency problem, which is copy on write. Now we're going to need to change it in game data. That's what we need to change. It's called copy on write ArrayList, control 1, hit enter. Now we do the same thing with this one, and when we instantiate it, it should be something like these. Okay, now when we run it, we should be fine. Next we'll add changing level, and game over to the game data. So go back to game data and go to update method. Now we are going to check if the pills has all been eaten, and power pills also. That means the level is clear. Here's what we do. We are going to set increment the maze number, and if the maze number is less than 4, that means we can move on to the next maze level. Otherwise the game is over. Simply I'll have one variable to indicate when to stop playing the game, so that variable is called dead. Now we are going to create a field called dead, which will be boolean. Initially this will be false. The drawing in Pac-Man would change to the following. So how about this? If game.dead, if not game.dead, I mean data, then do the whole thing. We have one error, which is date is not visible, so we'll fix it by that one. Change it to without private modifier. Let's go back to PackMan. Let's save it and go back to PackMan. Now in the draw method we are going to do these, and plus if data.dead will first draw transparent rectangle. So we are going to create a new color with transparency. This says gray with the 200 transparency. For the whole screen, and we are going to draw over to the center, which is width divided by 2 and height divided by 2, and we are going to move it up a bit to 50, and we are going to center it. Now let's move the goals. So go to game data and then implement this method. It will essentially be the same as moving Pac-Man, so we are going to go one by one. So for each of the goes info from goes info, the logic goes something like this. If we try moving according to requesting direction and it's a success, then we'll update the current direction to requesting direction. Otherwise, we'll try moving on with the current direction. Now the requesting direction is the info direction. That's it for moving ghosts. Next, let's implement the ghost code. Currently it only moves left, so we'll try something like this. We are going to create a new random object, and then let's control 1 first, and then now for each of the full ghosts we are going to random it from 4 that's how we do it. And now let's try running it. Whoa, here's the problem. Let's go back to game data. As you can see here, all of the ghosts are using the same position given by the ghost position in the maze. So here's how we can fix it. We are going to make a copy of position. Let's go to super. To make the copy, just say position, and we're getting the row from the given position object, and that would be it. Now try running this again. We should have okay, so here's the problem. When we try to move the ghost and we're giving in the requesting direction for all the ghosts, we need to make use of that somehow. So the code should be something like these, coming out that one, and for each of the ghosts, for each index of the ghosts from 0 to 4 to 3, and we are getting info from goes in for I, and that should be that. And requesting direction of the current ghost is getting from that, and that should be S. Now when we run this, we should be fine, and the ghost should be running separately. But the problem is the ghost is a little bit boring, so we'll make it a little more interesting by saying that each of the ghosts is going to travel the same direction, not the reverse, and if there are more than one option to choose, then we'll random it. So this is how we code it. First, we're gonna have a variable to return. Let's call it the direction, and for each of the direction we're returning, we're gonna need to get the options. The option should be list of direction. The option of direction that can be should be from data object get, let's call it possible directions. So it's the data.goes info I position. And now giving the list, we are going to remove the reverse direction of the current direction. So So list.remove data dot goes in for current direction. No, I'm sorry, that should be reverse of it. So that should be mover info dot reverse of that. Then the direction should be something like this. It should be from list.get, and the index should be from random. Next integer with the maximum of size of the list, and that should be fine. Now in order to remove an object from the list, we need to make sure that it's not an integer which would specify the index of the object to be removed. So in this case we are going to make an object or integer itself to match the object we are removing. Now what's left here is control 1 and select from utility class, utility package, and then control 1 to create it. Now here's how we implement get all possible directions. We returning the list of integer, and then for each of the direction we are going to check if position at that direction is not 0. So get position. Let's call it end post. Get next position in direction D from current position. If Macy's number character at in position dot rows and position dot column is not 0, then we can successfully move to that direction. Then we are going to add D to the list of the direction. So that should be next position in direction. Control 1 again, enter, enter. Now how do we do this? We are going to do the same thing, which is new row in that direction is from wrapping position dot rows in direction D with the maximum of Macy's number rows likewise column should be for column, and that should be maximum should be number of columns in the current maze. Now once we have that, we are going to return new position and rows and in column. If you prefer to make it one line, you can just forget about the variable in row and in column and put just wrapping function inside the constructor. But for me, I will leave it there, and then there's nothing wrong with game data. Let's go back to ghost coach. Still something wrong with this. We should be returning, so return the AR, hit enter. Now it should be fine. Now let's try it. Now we have problem. Let's I suspect that the list goes in false. Okay, the list should be. There's something wrong with. Okay, here's the thing that's go wrong. It always return no, so let's change it to list. Now this should be fine, hopefully. Why is it always move in the same direction? Let's check the options, shall we? I think it would just be there wouldn't be any options if it moved like that. So okay, it doesn't have any options. It always return 1. So there's obviously something wrong with get possible direction. Okay, the wrapping function is taking in the increment, so the increment is not the value of the direction. It basically the value of different in rows given the direction. So likewise, this is just that, and hopefully this is fine. Save all and then try running it. There's no interaction. Let's add ghost to the game. So let's go to game data, and then when the Pac-Man eats the power pills, all the ghosts should be turned into edible, but the edible time should be expired somehow. So let's keep track of the edible time by queuing it in an integer and decrement it each time we update it. So for each of the ghosts, the edible countdown should be reset to 500. Now this should be an integer, so control 1, create the integer there, and when it's not edible, it will be 0. Let's go back to game data. That should reset it. Next we are going to decrement it and then check for collision. Here's what we do for each of the ghost info. G in ghost info, if g dot edible countdown is greater than 0, I mean it can be eaten right now. If it can be eaten, we are going to check the position, if it got captured by Pac-Man or not. So if it is the same position, now I'm going to define touching to check for two position, namely ghost position and the Pac-Man position. If it's touching, then let's eat it and reset the ghost. Eat that ghost and reset. Okay, now let's define touching. Here is the implementation of touching. So let's first rename that to A and B. Now if A and B touching, it would be, let me define it to be 4 pixels apart. That means rows and columns are 2. Okay, this is how I do it. First, that the absolute of the distance between rows and columns of each of the position is less than 2. Okay, I can go to 3. That means if they are 4 pixels apart, then they should be touching. Let's go back here. Something's wrong with this. Oh, we haven't saved it. So save all of these and it should be okay. Now to eat the ghost, it means the score is going to be 100, and we need to reset the ghost in from the ghost position. So the current direction and requesting direction should be left originally, and position should be from the current maze ghost position. Anyway, just a copy of that. So let's just copy using that. Rows. Now that should be fine, and we should reset it. Countdown should be edible. Countdown should be 0 once we eat it. Otherwise, we'll just keep it countdown. Decrement it. Now, if it's not edible, we are going to check if it touch. Okay, let's copy that. If it touches, that means the game's over. Next, we are going to update the ghost drawing. So this is the normal ghost drawing. So to info edible countdown, it's actually 0. Otherwise, it's greater than 0. We should draw edible ghost. Okay, there's one more thing I need to add, because I want to give advantages to Pac-Man. I will only move the ghost if that's the condition, meaning I'll skip one frame and give the speed advantage to Pac-Man. And that should be it. The game should run fine when we run it. When we eat, it should be fine. Anyway, that is it for the series, for the whole series, and thank you very much for watching, and see you in the next game. Goodbye.